Hey everyone, we can get started and start with a new topic, which is the Terraform dependencies. Now, this is a very crucial topic because we need to understand that how Terraform dependencies are sorted out. Even though these dependencies are being taken care of automatically, but there are few scenarios where we want to enforce the dependencies so that we can instruct Terraform to ensure that the resources are being created, modified, or destroyed in the order in which we want. For example, I want to make sure that the VPC must exist before the instance could be deployed inside them. So in that case, I can enforce something called implicit dependencies. Or for example, I want to make sure that before the object could be uploaded to this bucket, those objects need to have the bucket first, the bucket name first, or the bucket must exist before the objects are being uploaded. So even though Terraform dependencies are being sorted out automatically, Terraform creates something called DAG, directed acyclic graph of dependencies between the resources out there. That graph basically deduces the order of the Terraform operations. Now, again, as I said, that we can influence these dependencies, we can instruct Terraform to provision, modify, or destroy the resources based on the order or based on the exact sequence of the order that we want to have. We want to customize that. So let's understand in theory first, what are the Terraform dependencies and what are the types of them. And we'll see in terms of implementation that how these two types of dependencies can be easily enforced in day-to-day scenario. So Terraform manages the resources dependencies to ensure that resources are being provisioned, created, updated, and destroyed in the correct order. There are two types of dependencies that we have, or we deal with. One is the implicit dependencies. Now, the implicit dependencies, they come into picture when we want to have a resources configuration which references the attribute of another resource. So Terraform automatically inputs implicit dependencies when one resource's configuration references an attribute of another resource. For example, the AWS underscore instance resource uses the ID of the AWS underscore VPC resource in its VPC underscore ID argument. So Terraform automatically understands that this instance needs the VPC to be provisioned first, so I must provision the VPC prior to the launching of the instance, right? These dependencies are automatically being detected by the Terraform graph building mechanism. It creates a graph that's called DAG, directed acyclic graph, which determines the correct order of the Terraform operations to be conducted. Okay, so we'll see that how this is implemented in a day-to-day scenario. Then we have something called explicit dependencies. Now, these dependencies are applicable in those cases when we have two resources which are not tightly intertwined or tightly interconnected with each other. And still we want to have a certain sequence enforced on those two resources while they're getting provisioned, they're getting modified, or they're getting destroyed. So the explicit dependencies are declared using the depends on meta argument within the resources block. This is crucial or necessary when a resource depends on another resource's behavior or existence. Now, just let's focus on this thing. But there's no direct attribute reference in the configuration that would trigger an implicit dependency. For instance, if a resource needs a specific service to be running before it can be configured, however, there's no direct reference to the services resources in the configuration, you would use a depends on meta argument to ensure that the service is provisioned first, right? So in this case, we want to ensure that even though those two different services or resources, I would say that, they're not tightly intertwined, still we want to enforce a kind of a provisioning order. We want to make sure that the resources are being provisioned, they are being destroyed or modified in the order we want, even though those two resources are not being tightly interconnected. Let's see an example. There are two buckets out there. I would say not two buckets, only one bucket. So there's only one bucket out there. There are two resources. One resource, the first resource represents a bucket to be formed first. So this resource block says that I want to create an S2 bucket. The another resource block says that I want to upload an object to this bucket, but this bucket must exist before this resource block or this resource object block ensures that this object is uploaded to this bucket. So to cut the story short, Of course, we're going to implement that and see how we can see that into in terms of the application and in terms of how it works for us. We are saying that there are two resources out there. Number one resource is a bucket. The other one is the object. The object is a file. It's a piece of data that is being uploaded to the S3 bucket. We want to make sure that before the object needs to be transferred or needs to be uploaded to the bucket must exist before that. Now, even though there's no any tight interdependency, because buckets can be created without the objects, right? So bucket, we can have the empty buckets out there. So we're saying that, okay, let's go ahead and just create a bucket. It could be empty. Then going forward, of course, we can upload any number of objects to it. But we want to enforce a certain criteria or a sequence, ensuring that the bucket must exist before the object or the objects could be uploaded to that specific bucket of our choice. Okay. Now, one thing that's very important over here is that even though we have two types of dependencies, implicit or explicit, we can use both of them. But it is very, very crucial that you should be using the implicit dependencies or give it more priority compared to the explicit. Reason being, the explicit dependencies make your code more complex and less readable. Okay. And the other downside of using the explicit dependency is that it hinders the parallelization during the Terraform operations. Now, what is parallelization? So Terraform uses the concept of parallelization, based on which it can provision up to 10 resources in a single Terraform apply operation. So you can provision up to 10 resources concurrently in a single Terraform apply operation. That's called the parallelism. Now, this can be tweaked if you want. That can be discussed afterwards. But the explicit dependency somehow suppresses the parallelism during Terraform operations. Also, it makes your code more complex and less readable. So I would say that you should refrain from using it. But of course, you can't completely avoid it. So try to use the implicit dependencies instead of explicit. Use explicit dependencies just in case if the implicit dependencies are not applicable or are not sufficient enough. Okay. So let's put that into practice. So what I'm just going to do that, I just open the Visual Studio Code and let's try to create a kind of a file out there and or a folder, I would say that. So let's name this folder and let's create a new folder out there. So this, I just go ahead and create a new folder named as TF. So we just create two folders out there. This first folder would be TF. This is for the implicit dependencies. Okay. So let's create this folder first and let's see how the implicit dependencies can be put into practice. Now I'll just create a file inside that, a Terraform file, a Terraform configuration file that's called main.tf. As we all know, we need to have a Terraform block, also include a provider block for AWS with the region as EU centered one, that's Frankfurt. So just right click and first thing first, I open the integrated terminal and I just go ahead and install the provider plugins by running the command terraform init. Okay. So this will initialize my working directory, which consists of my Terraform configuration file. So this is initiated. This is working behind the scenes. Okay. This is done. So the plugins have been successfully installed. Let's go ahead and let's try to work on the implicit dependencies concept first and see that how it is being implemented. So first, let's go ahead and create a first resource out there. The resource is the AWS_security_group. Now we all know that a security group is a firewall that we use in AWS that restricts the ingress and egress traffic. Ingress egress means inbound and outbound traffic with respect to an instance. So we want to make sure that the security group must be provisioned prior to launching of the instance. Okay, let's see that. So I named this security group as implicit-sg. Okay. Let's give some tags value or give one only tag, only one tag value is more than sufficient. So tags is equal to name is equal to, so this would be implicit hyphen sg. Okay, so let's go ahead and put that over here. The next thing that we need to put in or include the blocks inside the secure group resource are the ingress and egress blocks. So ingress define the inbound traffic. So we have to include the ingress block. Now in the ingress block, we just include the from port 80 and to port 80. So this is for the HTTP traffic. And yeah, so we need to also include the protocol as well. So protocol will have TCP. The two type protocols we deal with, TCP and UDP. And then we have the CRDR blocks equal to, we have to put that in the square brackets, which is the 0.0.0.0/0. Okay. So from port to port 80, which means that we want to just allow the ingress traffic 80 and protocol is TCP, and this is allowed from all the sources. Let's copy this ingress block and let's put that over here, and let's make some modifications, include port 443 for the HTTPS. Here we go. Let's include an egress block. So egress means the outbound traffic. So we need to make sure that we just include from port 0 to port 0. Now what is this 0? From port to port 0 means that we want to allow all the ports. All right. What about all the protocols? To include all the protocols, you have to include -1 in the single or double quotations. And CRDR block is equal to from, I would say, to all the sources, to all the destination, I'm sorry. So I'm saying 0.0. Of course, this has to be in the string format, 0.0.0/0. Fine. So based on the ingress and egress rules, we want to allow all the traffic from port 80 and 443. For the ports 443 and port 80, we want to the traffic from all the sources, I would say that. So we will have two ingress rules, two inbound rules. The first ingress rule will allow the port 80 traffic, which is for the HTTP from all the sources. Similarly, the second ingress rule will allow the traffic over port 443, which is for the HTTPS from all the sources. Then we have the egress, the outbound rule, which allows all the traffic to all the, or for all the ports for any protocol to all the destinations. Okay, so that's done. Fine. Now let's go ahead and let's declare another resource block. Okay, so this resource block, this is to provision my, so let me just make some comments out there. So provision, so we're going to just create and provision a security group, or okay. So we're just going to go ahead and create a security group out there that will be later on attached to the instance. The second resource block, so this is my resource one. Okay, so this is my resource one out there. This is my resource one. This is the first resource is the security group. I think this will be more relevant in terms of including the comment. And the resource two would be the Amazon EC2 instance. So it's named as EC2 instance to make it more simplistic. Right now, let's create a resource block out there. AWS_instance is the resource type, and let's name it as, for example, implicit -instance. Okay, here we go. Now, of course, we have to include some basic attributes. We have to include AMI. Okay, so I just pick the AMI from the I would say that AMI catalog. So I can just pick the Amazon Linux to AMI, just copy and paste that over there. So let's copy this thing. Let's paste it. Of course, we have to include that in the double quotations. Is in string format. Instance type. Okay, so instance type would be, let's go with the teacher.micro because it is free tier eligible out there. All right. And we also include the tags value where we say name is equal to, this is my implicit -instance I think this will make sense. This will be more relevant, I would say that. And that's it. So this is my resource 2, I'm sorry. Okay, now one thing we need to understand over here is that there are 3 main attributes that we have applied to this instance resource: AMI, instance type, and tags. We'll include the 4th one, which is a VPC security group IDs, which includes a list of different secure groups. That's the reason we have to include the square brackets. And automatically shows me AWS underscore security underscore group dot implicit hyphen SG. And I include the exact attributes. This is the resource dot ID. Okay. So I'm saying the VPC security group IDs. Now you can attach up to 5 different security groups to an instance or load balancer. So that's why we have a list of that. So we can just give a comma. So okay, it can be a comma separated value, and we can also define a different ID over there. But in this case, of course, we'll just go with only one security group to be assigned to the instance. So we're saying that this resource, which is my AWS underscore instance, resource type AWS underscore instance, resource name implicit underscore instance, that's the resource address, requires a VPC security group ID. So it references to this one, this security group. You can see that AWS underscore security underscore group dot implicit hyphen SG dot ID. So this is a classic example of the implicit dependency. Okay, fine. Now let's go ahead and let's put that into action. First thing first, we want to, okay, let's do one thing. Let's format this thing. So let's format these files first. So I just run the command Terraform fmt so that they're formatted in the canonical format and style, and we just do the validation check so that it can ensure the syntactical and logical integrity of the code. I think everything is valid. So let's go ahead and just run the command Terraform apply auto approve. So let's go ahead and just put that over here. Let's execute this command. Now, of course, you're going to be seeing one thing. As it is just processing everything at the back end, the very first thing that it's doing is that it's creating the security group first. Right? Now, I didn't instruct it to do that exclusively, but based on this implicit dependency concept, it automatically deduced or concluded that this instance, this resource block, depends on the resource, which is the security group. This must exist before this instance can be launched. Hence, as you can see that the process is over, the security group is created first, followed by the instance. So this is an implicit dependency concept that we have just enforced, based on which Terraform automatically understood that the order of the operation or the provisioning of the resource. So it got to know that yes, I have to provision or create the security group first. Then I have to just go ahead and launch an instance. And that instance will use the security group ID of that security group. Okay. Enough talk. Let's see that whether this is applied successfully or not. So I just go to the instances right now. All right, this instance is launched very well. So let's go to the security option. And this is security group. I click on that one. This takes me to the security group dashboard. You can see that based on the tags, this is applied. This is the same security group that was provisioned. Okay. Let's go to the inbound rules. Based on the ingress rules, we have the HTTP traffic from all the sources, which uses port 80. HTTPS, which uses port 443 from all the sources. And the egress to the outbound allows all the traffic for all the protocols to all the destinations. All right. So this is the security group ID of this security group, which is auto-site, which is auto-generated. So based on the implicit dependency, this instance requires the security group ID of that security group to be provisioned. So this means that the security group must exist prior to the launching of the instance. So we have enforced the order of the operations or the provisioning of the resources out there. Okay, so that's how this is being done. So I'll just go ahead and destroy everything. And in the next part, we'll see that how we can just apply the concept of explicit dependency. So let's run the command terraform apply and this destroy. And let's auto approve that so that we don't have to give the consent after that. And this is being done. All right. Okay. So this is working behind the scenes. This will destroy everything. So in the meantime, I'll just go ahead and create a new folder out there. And this folder name would be TF Explicit Dependencies. By the way, all the materials and all this code will be included in the resources section. You can just download that. I'll just include either a Google Drive link or a OneDrive link. So you can just fetch this code from there or all the resources or the document that I've used for the theoretical overview. All right. So I just go ahead and just make the correction in terms of spelling. Okay. So let's create a new folder, or I've already created a new folder, TF Explicit Dependencies, and create a new file out there, main.tf. And as always, let's copy and paste this Terraform and provisional block. Let's paste it as it is. Right click, open in the integrated terminal. Let's initialize the working directory. And this is important. This is the first crucial step when you're just working on a brand new Terraform project out there. Okay. All right. So now in this case, we have to see the explicit dependencies. Now, as I've discussed with you earlier, the explicit dependencies concept is all about enforcing the order of the Terraform operations, which means that we enforce that 2 or 3 resources are created or destroyed or modified in the sequence as we want, even though those 2 resources may not be tightly interconnected with each other. Fine. But we want to enforce or put forward the sequence of the provisioning or modification or the destruction of those resources out there, especially provisioning. Okay. So let's create a resource out there. And this resource will be AWS_S3_bucket. I name this thing as explicit_S3_bucket. Right. Let's put a simple name out there. Okay. And let's have this bucket name equal to, put my first name, and I say explicit S3 bucket. Now, whenever you assign a name to the bucket, you have to follow some naming conventions. Everything should be lowercase, no caps allowed. It can be alphanumeric, and only 2 special characters are allowed, hyphen and a dot. So you have to be cautious about these different naming conventions out there. So that's it. I think we don't have to put anything forward. That's more than sufficient. We just assign the bucket name. So what is this first resource out there? This is the first resource. So resource 1. I'm sorry about that. So resource 1 is this is my Amazon S3 bucket. So this is my bucket that we have just provisioned out, or will be provisioning. I'm sorry. So this is my Amazon S3 bucket that we're going to provision out there. Fine. What's the next resource? The next resource would be the object that would be uploaded to this bucket. Okay. Let's copy this. Okay. Let's go ahead and create a resource block. And this is my second resource out there. Resource 2. This is the object. So this is the S3 object. Yeah, S3 object. I think that would be more relevant in this case. Resource would be AWS_object. Okay. Object. Okay. So what happens is that whenever we AWS_, let me just put that up one more time. So AWS_S3_object. Yeah, that's the one. And we have to put that simple name over here. For example, I can say this is my explicit S3 and this is my object. Okay, and that's it. We'll just go ahead and include certain attributes which are I would say which are mandatory. The first, I would say, the first attribute which needs to be put on over here, or which needs to be included in this resources configuration, is the name of the bucket to which this object we're going to define would be uploaded. So of course, as copy and pastes this bucket name as it is. So I'm saying that this resource block, which allows me to upload an object to the bucket, I have to define the bucket name. So I'm saying that the object that we're going to define over here would be uploaded to this bucket with this bucket name. All right. Then we have to define the source. So source means that the directory from where this file will be fetched, the exact absolute path or relative path. So what I'll do that. I just right click and open the terminal and just run the command touch explicit demo file.txt. Yep, that's been created right now. You can see that on the left hand side. Right, this is an empty file. And I will go ahead and now I will say the source would be in the double quotations dot means the current working directory /. So the name of this file is, so it's copy and paste that so that I don't make any typo errors while just including that. Okay. And then we have the key. Key means that what is the name of the object that will showcase itself as an object name when we upload that to the S2 bucket. So I'll keep it as it is. Fine. Okay. Now here where we can use the explicit dependency. So I say depends on and automatically populates the bucket over here. So this is the example of what we call as an explicit. So we are saying this is the explicit dependency. Depends on. Based on the second resource configuration, we are saying that this resource block will be executed successfully if this resource, where it's on the top, exists. Right? So this means that this first resource block will be executed first. Now again, it's not the sequence that we have defined the configuration. Right? We are saying that the resource 2, which is an S3 object resource block, would be executed only and only if the first resource block is provisioned successfully and the bucket exists already. Okay. If it does not exist, then of course the second resource block will not be executed. Okay. So let's do the formatting, Terraform FMT, and let's also do the validation. Okay. We want to validate that there are no syntactical or logical inconsistencies in our code. It's success. And we say Terraform apply auto approve. So let's go to approve that or give the consent for this application or for the provision of these two resources out there. As you can see, the bucket is created first. The first resource block or the bucket resource block is processed, followed by the object resource block. Okay. So that's the beauty about or this is the I would say the crux of the dependencies, that we can enforce our own order of the resources that can get provisioned based on our preference or choices. Okay. So let's go and just verify that whether these things have come into effect or not. So let's go to this tree. And I just go to the buckets right now to see the list of buckets. Let's go with by the creation date. And yes, you can see that this bucket is formed. And this is the object with the key name that's being displayed over there. Fine. So to cut the story short, Terraform manages resource dependencies so that the resources are created, destroyed, or modified in the correct order. It uses something called DAG, directed acyclic graph of dependencies between the resources, And this graph basically enforces or it deduces the order of the Terraform operations to be conducted, which means that this graph determines that in which order it has to create, destroy, or modify the resources. But we can influence it using implicit dependencies or explicit dependencies, right? So that we can instruct Terraform to provision the resources in the correct order while ensuring that some of the resources or some critical resources exist before other resources could be deployed. So I hope that this was informative. Thank you.